Are you wondering whether a career in data science is suitable for you? I have compiled 6 questions to assist you in determining it. If the answer is yes to all of them, you would likely enjoy a career in data science. I've been working as a data scientist for almost a decade and teaching this material for 4 years. Yet, there are still many things I am not as familiar with as I would like to be. For instance, I do not know too much about the practical aspects of database engineering, and I am not as knowledgeable as I should be about deep learning. I'm trying to learn as much as I can through online and in-person courses, reading publications and blogs, and experimenting with new tools. Learning in this field never ends, not even for professors. The truth is that no one knows everything there is to know about data science because it is too vast and rapidly evolving, so you constantly need to develop yourself. I personally find that very exciting, but that's not necessarily true for everyone. So you need to have a mindset where you are open to learning new things if you want to succeed. Learning new things comes with a certain level of discomfort because it's not easy to change how you think, and you need to be fine with failing and making mistakes as you learn. If developing machine learning and deep learning models is what you enjoy the most, do not become a data scientist. Consider machine learning engineer positions instead. I can tell from personal experience that data scientists spend as much as 70 to 90% of their time preparing datasets for machine learning. They engineer features, collect external data, and the like. Only a small amount of time is spent on actually developing models. Datasets are messy. The information you need to solve a problem might be scattered over many databases. Sometimes you need a small subset of points or features from a database. Sometimes you need to collect external data, and you will almost always need to engineer new features to improve the predictive power of your models. These tasks are difficult and open-ended, which brings us to the next question. Working on data science projects is not like solving homework assignments. Assignments are usually pretty well defined, you know there is a correct solution the instructor is looking for, and you can compare notes with your fellow students. In contrast, data science projects are almost always ambiguous. The problem might not be well defined at all. Your manager or the company's stakeholders might not have a clear idea of what problem they actually want to solve. Often, it is your job to determine the problem and phrase the question. It's also true that you do not know in advance if the question can be solved because you might be the first one trying to solve a particular question with a proprietary dataset. One problem can be solved in various different ways, and it might not be immediately apparent which approach you should take, and you might not have enough time to try them all. This ambiguity can be pretty frustrating for some people, because if your model doesn't perform as well as you would hope, it could be that your data quality is not good enough to answer the question, maybe there is a bug in your code, maybe the tool you use is not appropriate for the problem, or maybe you just need to engineer more and better features. It can be difficult to figure out what exactly is the problem. Scrappiness comes from the fact that sometimes you will be given really tight deadlines to answer questions, and you won't have time to be thorough. Usually, you will just have to do the best you can given the time you have available and then move on to the next question or next project they want you to work on. For perfectionists, this can be really unsatisfying, and it takes some getting used to. Stay tuned until the end because the final question will surprise you. Math is absolutely crucial for data scientists. Statistics, probability, linear algebra, and calculus are all necessary if you want to succeed in this field. You might be asked to perform various statistical analyses like hypothesis testing. Exploring datasets requires some basic math skills. Machine learning models are based on linear algebra and calculus, and you will need to understand how these models work, what the pros and cons of various models are, which hyperparameters are important if you hope to apply them successfully. My students often ask me, why should we know how machine learning models work? They are all implemented in Python packages like scikit-learn, Keras, and TensorFlow. While that is true, there is a lot more to machine learning than import scikit-learn. I spend a lot of time in one of my courses illustrating what kind of errors one can make if they are not careful and don't understand the mathematics and numerical algorithms behind the models. Information leakage, convergence issues, and mistakes in cross-validation are just a few examples. While the packages are nice and allow people to quickly and easily train models without necessarily understanding what's going on behind the scenes, this can also be quite dangerous. Strong communication skills are another requirement for successful data scientists. Consider this. You might develop the best models and produce the most mind-blowing results, but no one will care if you cannot communicate your results effectively. This is also where the business needs of the company come into play. First, you need to understand the business needs of the company. Then, you need to explain to non-data scientists how your results and insights will benefit the company. If you cannot do that, they will not implement and use your models. Unfortunately, the divide between technical and non-technical people can be pretty huge. For example, I was once explaining my data analysis results to business leaders, and they asked me to explain what a logarithm is because I used log axis on one of my visualizations. I think this point is often overlooked. It's called data science, not data feelings, not data opinions, or not data beliefs. Your job is to make decisions based on data and experiments, constantly questioning your beliefs and change them if new evidence presents itself. Always ask yourself the fundamental question of rationality. Why do you believe what you believe? What do you think you know? And how do you think you know it? Let me give an example. Students work on a final project in one of my courses. Their task is to find a dataset and develop a supervised machine learning pipeline using it. Sometimes they chose a large dataset with hundreds of features, and they want to drop some features because they don't think those features are important. Wrong. They have no evidence to support their claim. It's just a feeling or an opinion, usually motivated by trying to take shortcuts. This type of thinking is quite dangerous. They have no evidence to support that the features are indeed unimportant. If they were to drop those features, the performance of the model could suffer as a result, which can have severe consequences. What I tell them is to use all features and train the model. Most machine learning models have ways to measure how important features are in making predictions. Once they train a model, they can use those tools to measure the importance of the features and then decide if it makes sense to drop some. And finally, retrain the model and make sure the performance indeed does not drop. If you answered yes to all 6 questions, congratulations! You would likely enjoy a career in data science. Let's continue your journey and learn about 3 things you need to know to become a data scientist.